This is for Year 12 methods. It's the 2010 Tech Aloud Probability SAC, looking at question 4D. Question 4 starts off a discrete probability distribution, n, where n could be 1, 2, 3 or 4, and that's a spinner being spun. They weren't equally likely, and when k equaled 2, I had the distribution that's at the top there. When getting a 1 was 7/14, getting a 2 was 4/14, getting a 3 was 2/14, and getting a 4 was 1/14. So the first part of question 4 looks at discrete random variables. When it says the spinner is spun 6 times and the number of markers landed is noted, it becomes a binomial. And in question 4, the binomial distribution is about getting the number of 3s. So in question 4 it reads, what is the fewest number of spins? That is, what's the value of n? I don't know n. Required for the probability to be 80% sure. Therefore, my probability has to be greater than 0.8 of getting a 3 at least twice. So I now have t as being a binomial. I don't know how many spins there are, but the probability of getting a 3 is 1/7, and I get that from the table. So I want the probability of t being greater than or equal to 2, because I want at least 2 3s, to be in order 80% sure. So to be 80% sure, I want it to be 80% or more, so I want it to be greater than 0.8. T is a binomial distribution because t is the number of 3s that I spin. The probability of getting a 3 is 1/7, and I don't know how many spins there are because the question said, what is the fewest number of spins required in order to be 80% sure of getting a 3? Okay, that's the structure that I have. T is a random variable. I can have no 3s, I can have 1 3, I can have 2 3s, 3 3s, 4 3s, 5 3s, up to n, the number of the number of spins that I have. Okay, because this is open-ended, t could be 2 or 3 or 4 or 5 or 6 or 7, all the way up to n. I'm going to turn this around and make it 1 minus the probability that t is less than 2 is going to be greater than 0.8. Which means the probability that t is less than 2 is greater than 0.2, less than 0.2. So the probability that t equals 0 plus the probability that t equals 1 has to be less than 0.2. Okay, since t is binomial with n and 1/6, getting a 0 would be getting none out of n, 1/7 to the power of 0, and 6/7 to the power of n, plus n1, getting 1 3, and 6/7 to the power of n minus 1 has to be less than 0.2. That's equal to 1. That's equal to 1. So that's 6/7 to the power of n plus, that's equal to n, that's 1/7. That's 6/7 to the power of n minus 1 is less than or equal to 0.2. I can do this a couple of ways. I'm going to jump onto the calculator. On the calculator, enter this, and I could look at a table of values, I could graph it, or I could solve it. Okay, but I'll enter it first. So bring up the keyboard. I have fraction 6/7. Oops. Okay, so there it is entered. 6/7 to the power of n plus n times 1/7, 6/7 to the power of n minus 1 is less than 0.2. Now, I'll go in decimal. If I try and solve that, it doesn't give me an answer, it just gives me in terms of x, so it didn't solve it. So what I'll do is, I will open up a window, I will take this, I'll drag and drop, I will take this, I'll drag and drop, and it looks as if there's an answer over here that's negative, and there's an answer way over there that's positive. So I'll change my window and I'll go from 0 to say 40, and I know it's 0.2, so 0, and I'll make that 0.4. Okay, and there is my graph. So when n is smaller, the probability is greater than 20%, but when n is bigger than this value, the probability is less than 20%, which is what I want. So analysis, G-solve intersect, and the intersection is 19.93. Therefore, I want 20, because when it's 20, this will be less than 20%, therefore they'll be greater than 80%. So 20 should be my answer. How else could I do it? If I take this and I copy it, and I jump out and I go into graphs and tables, and I paste, and I'm interested in execute. I'm interested in looking at some table of values. I know it's 20, so how about I choose 30 where I end, and I'm going up by 1. Okay, and I look at this table of values. I'm looking for when does the probability get to less than 20%, and we're still above 20% there, but we're below 20% there, therefore 20 is the number of rolls that I want.